Hello everyone, my name is Kris Verlaenen. I'm the architect of the Red Hat Business Automation Platform, which is a supported offering on top of the open source GBPM project and some other related Red Hat products. We're all aware that nowadays applications are becoming more and more intelligent because we've been offering ways to encode that knowledge for years as business processes, as rules, as decision tables, etc. However, AI is actually changing that. It's adding another dimension to this because rather than relying on humans to kind of figure out those relationships and encoding them as part of the business logic, machines are now going to try and learn directly from data themselves. So what we want to do is we want to make sure that we can apply machine learning to how we're already using business processes and other technologies to automate behavior, automate human behavior, so that we can apply it in very specific situations so that the system can become smarter over time itself. There's various roadblocks in trying to apply machine learning because it's very complex, there's a high setup cost, etc. However, business process automation has shown to be a great enabler for technologies like this. New technologies, they can really use the platform as a foundation because it's got lots of access to data, whether it's historical or live data, and integration points where these kinds of technologies can plug into. And so one of the other challenges that we've seen is also, and we talked about that, the kind of the fear of kind of applying AI in real life use cases. So again, this is something that even with business processes we've seen in the past as well, although to a much lesser extent, is to try and automate behavior of humans. So what we want to do is we want to make sure we can take small steps so people can build up confidence and they can kind of gradually start using more and more features and select specifically in which area they want to do that. And so we focused on human tasks where we're absorbing and augmenting the data that's being processed by humans in that context. And eventually, we could even fully automate some of that. But to be honest, that's not our primary goal. To be able to integrate machine learning, we kind of have to do basically two things. One is you need to have the data and continuously be training the models so they become more they can become smarter, and then actually to integrate the prediction into in those tasks as well. The algorithm we've used to kind of link to kind of predict the task outcome based on the incomes is called random forest. So basically, those are a lot of decision trees which we're training in parallel. In the demo, I'll be using the Smile engine, which is a small embeddable engine which comes out of the box with an implementation for random forest, like actually most machine learning products or libraries out there. We're kind of doing something similar with Apache Spark as well. But to be able to take small steps in applying machine learning, we focused on non-intrusive ways of applying machine learning. So the first approach is that we're basically just going to add additional augmented data to the task that's being executed. And this could be just trying to do a prediction of what we believe the outcome of the task could be, but there's lots of more information we can show, like the confidence we believe in that prediction, the kind of parameters we've been using to make that prediction, etc. A second non-intrusive way of applying machine learning is to do task recommendations. So we're going to recommend people to do a certain task. And that's especially useful in contexts like case management, where we see lots of dynamic and ad hoc tasks being used, and we can learn from those. Both of these approaches could be fully automated, meaning that if we've got enough data and we've got enough confidence, we could eventually have that algorithm replace the human user. But that's really not our goal. Our goal is really to assist those users. And then finally, the last approach is to learn from what the machine learning algorithm has learned, to try and analyze that and figure out what we can do with that, optimize the process we have to be able to do that. So we focused, even though we know that machine learning could be used to kind of try and replace some of the human actors, we focused on just trying to help those people that are executing these tasks in a non-intrusive way. I'll get back to this slide at the end of my demo because, trying to share some of the lessons we've learned in that context because, machine learning comes with its own challenges as well. And in the demo that I'll show, I'll basically be showing those three approaches that I mentioned. So the approach of augmenting task data while you're executing, recommending tasks and learning from whatever what the algorithm is doing, and trying to use that to optimize the process that you have. All right. So the demo that I'll be showing, maybe I should just put it on here. The demo that I'll be showing is a simple application that employees can use to need to refresh. All right, I need to restart my service. So what I'm basically going to show is a simple application that employees can use to order IT hardware. I mean, for their office, whether it's chairs, etc. Anything you can order. Specifically, I mean, like laptops, etc. that you can order. It's a simple case application. So basically what it's doing is, and I'm only going to focus actually on the first part of the application, but in the end, so you're going to submit an order, it needs to be prepared, and then a manager needs to approve it, and then in the end it's going to be placed, and then based on the data, so it's a kind of a database process. There's these fragments which are going to be triggered under certain circumstances to, in the end, actually get, obviously, the laptop shipped to the employee. And a kind of additional task related to that. So I'm going to just show that without any machine learning associated with that first, and then I'll show how we're going to apply machine learning in that context to improve that behavior. So this is as an employee, if I log in, this is kind of the page where I get to if I want to order a laptop. And so in this case, I can just, as a user, I can select that I want an Apple laptop. I can submit that order. And then, I mean, this is a customized application specifically for this use case, where you can then, as a user, go and check the current status of your case. So the case has started. Nothing actually has happened yet. So I'm just waiting for the case to be processed by all the different actors to be able to do that. So the next step is then that if I log out and I log in back in as a vendor, I can see that because someone has ordered a new laptop, as a vendor, I would actually need to send the specs of the latest model that's currently being shipped. So I can basically attach a file here and send that back. Again, nothing extremely difficult. This is just walking through the case, and I can log in myself as a manager and decide whether I want to approve or reject this order. So there's basically 3 people in this context. And I can decide to approve this. I know I can see who ordered it and basically approve it, and then I can go check the state again. And as you can see, we've walked through the hardware specifications done, and the manager's there. So let me now, in the background, trigger a script that will start doing this automated for a number of cases. So in the demo, I mean, it's very difficult to really show a large amount of data. So the use case that I'm showing is still fairly simple. On the other hand, that's what we see when we apply machine learning, et cetera, is that sometimes you don't necessarily need to apply it to fix the most complex issue that is out there. Like, I mean, whatever the machine learning is going to be detecting, sometimes it's actually fairly trivial. Like, if you look at the issue, you're like, well, I could have figured that out myself. I could have encoded that in the process. But the issue is you haven't. And so, I mean, to be honest, what I'm like, if I see what I'm doing on a regular basis, some of those things could be automated. That's great. But they haven't been. So I end up doing those things day after day, every time again, simply because they haven't been automated yet. And that doesn't mean they couldn't be. Like, I can easily try and figure out, okay, this is like a problem that I have. I can automate that, and at that point, that work will disappear. But then you have to still do that. And the advantage of using machine learning is that it will start picking up some of those things. It will start detecting that some of the work you're doing is actually something that we can automate, and it'll try to help you with that. So if I now go back and look at the pending tasks. So I've now run through 20 use cases, and the use case is fairly simple. I've got two users, I got Magic and I got Mary. They're both ordering laptops. They're ordering different kinds of laptops, and I'm just observing that system. So it is as if like a real manager went in and he decided, yeah, Magic, he can order this laptop, and Mary apparently can't. So we're just observing that data. We're seeing that. And after a while, we can actually try to see, like, well, actually, can we make a recommendation? If a new request comes in, can we actually help the manager in deciding what he should be doing? So again, this is the same form, but what we've tried to do is we try to make sure that we can actually augment the data that the manager has access to by saying, okay, what we see here, this is a request. We've seen similar requests before. And in this case, we're actually recommending you to approve this order with a very high confidence. And we can give information about why we believe you should be doing that. So I think one of the challenges is that even if we can have a recommendation, sometimes it's difficult to figure out why that's the case. And so the algorithm itself actually has much more information other than just the result that you want to recommend something. So in this case, we're making a recommendation of accepting it with a very high confidence, which, I mean, in this case, is actually not that realistic, because I'm giving it very consistent data. And it figured out what a pattern is, and it believes it has figured it out, and it's with a very high confidence. And it does that based on not whatever laptop you're ordering, because the relative importance of whatever laptop you're asking is very low. It's basically based on who's requesting this. So it's figured out that actually this is the relevant parameter that you're going to be using with a high level of confidence. In realistic situations, what we've noticed is that in general, you never get to this kind of confidence, yet even at a lower confidence, this kind of information is very useful. So to give you an idea, if I give it very consistent data, this is just a plot of kind of the data that the algorithm is putting out. And so initially, if it hasn't seen any data, after a while, you can see, and so there's a confidence on, this is the confidence on approving the order, and this is the confidence on rejecting the order. If you give it very consistent data, it'll quite quickly go to a confidence level where it believes it's seen this before, it's figured this out, and it'll believe it can give you the right recommendations. Also, it fairly quickly figures out the importance of the different parameters. It can figure that out as well. In a more realistic situation, and that is like in situations where the data isn't as consistent, you will not get to very high confidences. Like in this case, we start in the same way, but at some point, I kind of changed the order. Decide Magic's no longer getting any laptop, Mary is. At that point, the algorithm obviously detects that, and it's like, well, it's no longer able to give a high confidence. It's actually kind of jumping. Actually, it's rejecting orders which probably should have been accepted and vice versa, because it figured out it doesn't know anymore. That doesn't mean that that kind of feedback is useless. We know that we will never want that to fully make that decision autonomously, because, I mean, it's probably wrong, but it knows that itself. So what we just want to do is provide that kind of information while you're performing the task. It might be useful, it might not be, but we allow you to choose for specific situations, not for all tasks, because, I mean, doing machine learning on all kinds of tasks, lots of tasks, there's no clear correlation between the inputs and the outputs. For those, it's actually not that useful to try and apply machine learning to figure out these constraints. But for some cases, it actually is pretty simple to do that. So so let me just approve this one. The second approach is is the task recommendations. So again, in this context, so this is a case, and we've seen this before. Cases allow you to dynamically add any kind of task to the case so that it becomes part of the case, even though it wasn't designed to be part of the case. So the use case here is that if you're buying a laptop, there might be legal consequences to do that, or HR consequences. Because, like, for example, in Belgium, if I get a laptop from my employer, it has tax implications. It's considered a benefit, so I actually have to contact my HR or my legal department to notify them that that happens. And let's assume that the manager is responsible for making sure that the employee knows that. So in this case, even though this was not defined as part of the case logic, we know that managers will go in and dynamically start doing that. So they know, okay, I do need to do this, so they actually do that. So in this case, if I would just do this, it would make a new recommendation, would create a new task so that the employee will contact the legal department with this kind of information. If I start monitoring that kind of behavior again, the machine learning can actually start picking up on that as well. And rather than the machine learning triggering that task, we just want to make sure that we make it easier for the manager to do his work. So we've introduced the concept of a recommendation. So this is not an automated task. This is actually something where we just say, based on what we've seen so far, we believe that probably this is what you should be doing. The manager's still fully in control. He might say, well, actually, you're wrong. And similarly, there's additional data we can give you around confidence, et cetera. But in the case where actually we figured out something which is right, this makes it much easier for the manager, because all he has to do is he will be reminded that he should be doing this. So in case he forgot, actually, the system will help him, and he can still decide whether it's relevant or not. Because in my background in clinical decision support, et cetera, this has been the key concept that's needed to apply even just basic processes, et cetera, in that context, because no one is willing to accept a process making decisions on like how to treat patients, et cetera. They don't. So a concept of a recommendation is a much less invasive way of doing this. And then finally, the last approach is that the algorithm, like I said, the random forest, it's a large number of decision trees all being trained in parallel. And we can extract that knowledge back from the algorithm. So we can look at what it believes it has learned so far. So in this case, again, it's a very simplified case, but that's not necessarily a big issue. But this is what it believes it has detected so far. So I've been feeding it information on laptops, and I've been adding where the employee actually lives. And it's figured out that in Belgium, that actually people have been constantly contacting HR. So if the employee lives in Belgium and you're buying, in this case, an Apple, so it thinks like if you buy an Apple laptop, then you should contact HR. Now, this is a simple tree where you then can go and look and say like, okay, this is what we've detected. Does this make sense? So I think that's the first question always like, well, does it make sense? And if it makes sense, is it correct? Because it could just be detecting something that you shouldn't be doing. And so the third way, what we believe you should be doing with this machine learning as well, is you should learn from this and optimize your business process based on that data. Because you could look at this and realize that this is valid, and then say like, okay, I'm going to build that into my case, into my process, so and do it, encode it in the right way so that everyone will be following this. The advantage is that you look at what you've learned so far and apply it and analyze it and then put it back into the process, rather than saying, well, the machine learning has figured it out, that's great, we'll just keep relying on it, because there are disadvantages on relying on machine learning as well. So basically, if I go back to my project and open the business process that I showed so far, you can use existing features, etc., to improve the process that we had to make sure that some of the things that we've detected so far, that we can re-encode them into the business process. So we can, and I'm not sure, this is, oh yeah, there we go. So I made an enhanced version of this process. So that's the new version that you can then deploy and make sure that this will be the next version of the process you'll be executing. You can take advantage of lots of these things. So for example, this is a very simple approval rules you can add. And in that, you will encode, let's say, in a DMN table, under which situations managers do no longer have to approve till some of the things can be auto-approved. We can use rules as well here to make a decision on some of these tasks. And the concept of ad hoc tasks, so there's a difference between ad hoc tasks and dynamic tasks. So dynamic tasks are something that you haven't modeled at all, but while you're executing, you can add it to the case anyway. What we're doing here is we're turning that into ad hoc tasks, which means we are modeling them, but we're only triggering them under certain circumstances. So that already, so what we're doing is we're turning this recommendation into actually something that we're modeling here, so we can execute that. So again, this means that even though the machine learning might have been detecting certain things, we analyze that and we try to use that as a basis to improve our processes. And then the final part, I guess, is the slide on some recommendations. And some of these, we've been talking about this already. So this is not necessarily all new. But so one of the challenges is that the machine learning can only be as smart as the data you give it. And the amount of data, if you just look at the task inputs and the task outputs, that's very limited. Because usually there's a lot of associated information. Like, for example, if I only know who's ordering the laptop, I also need to know much more information, like which country does he live, what kind of employee is it, how long is he working? So, because that might actually be the reason why you're making certain decisions. The advantage of using random forest is that it's very good at determining itself which parameters are relevant. So the advantage is that you can feed it a lot of data. You don't need to make a pre-selection on, okay, this is relevant, because you don't know. It's very good at trying to detect that. That's why the relative importance of these parameters is very useful as well. So what we allow you to do is, using a sort of annotated approach, we allow you to kind of load additional data based on whatever the task has as input. So we know that if the task has an input regarding an employee, our integration allows to get additional data about that employee and adds that into the machine learning algorithm as well. That makes it that it's able to detect many more relationships than if you only feed it the direct inputs. We also want to apply it in only specific situations. So we identify tasks where we want to apply it. Just applying it to all tasks is probably just going to lead to bad results, because a lot of tasks really can't be predicted. And we've talked about bias before, because if you can actually have the machine learning algorithm picking up on some people abusing a loophole in the system and starting to recommend to other people that they should be using the loophole. It's great. Those people will probably find that as assistance and they're helping their job. On the other hand, that's why you analyze that. You will figure out that there's an issue with that, and you will encode it so they're no longer able to do that. So that's why the analysis, et cetera, is what we do, and that, yeah, you don't necessarily learn the correct behavior. So that's why I strongly believe in using the machine learning to assist, so that even though it hasn't been encoded in the business logic, it still gets smarter over time. But to use that as an input to then use way more, explainable logic. Whether it's make sure that whatever it's doing is not what it learned, but is what it should be doing. And so it's a combination of both technologies I think is ideal to kind of combine the learning capacity and helping, but over time then to figure out how to improve the process you have to deliver that. All right, any questions? Yes.
So, have you made a conscious choice of using machine learning as opposed to process mining in this situation? Because fundamentally, you know,
Yeah, I guess it depends. Process mining, there's lots of different things. So if it's really about looking at historical data and trying to figure out what people are using, then I guess that's not what I think is the technology fit to kind of do these things. Although, for process mining, et cetera, we're kind of more dynamically figuring some of these things out. So there's maybe just an overlap in some of these technologies. I think the key here is the kind of the automated learning here. I think it doesn't really matter how you do it, because we used here for task input versus task output, we used random forest. There are other algorithms. This is not like deep learning. This is not image recognition. This is not natural language processing. These are other technologies. There's other techniques that you can use to kind of try and achieve something similar,
so
yes.
your point is the outcome is important, the how is just...
Yeah, and I would argue not just the outcome, but then the additional information you can provide as well. Not just, this is what you should be doing. Really, any algorithm that can augment the data, or augment the data that the user has access to make his life easier. And like I said, not necessarily it could be making his life easier by doing the task for him, but usually that's not possible, or not easily possible. Then you need well-trained models, much more effort, et cetera. So we've been focusing on the effort of assisting those users. Yes?
Yeah, so as you mentioned, some of the tasks are hard to learn. And imagine there are rules that are, business rules that are temporal, let's say, or depends on the class. Imagine a rule in this example. Over 18 months, you have 1 or 2 quota for a laptop or devices.
Yeah.
And that is very hard to learn given temporal tasks. You can easily say, oh, the first one everyone gets, the second one now I'm not getting it.
Yeah.
So I wonder how you reduce the noise, because it's not becoming clicky here. I'm going to do something. You become oh no, this is wrong because you're not figuring it out.
Yeah, so I think that's why, that's one of the reasons why adding as much as data about the requests, not just looking at the task inputs only, but adding context data. Because like you mentioned, one employee probably orders 1 laptop every 3-4 years. So associating like 1 user with approval or not is going to be pretty useless. But you need to then start looking at all these other parameters. Like, for example, contractors are maybe not allowed to order any laptops. You can only figure that out if you've seen enough cases of people requesting one where you know that contractors and figure that out. The more complex the relationship, the more data you actually need. And that's why I fully agree, and why we've only tried to apply it in specific situations to try and detect, to be honest, fairly simple patterns usually. Because the more complex it becomes, the more unlikely it is you will quickly be able to pick up on that.
So the question is actually, given that, is a human decide, go monitor this task, or the system is allowed itself to figure out? Because some of them are not suitable.
Yeah, so currently how we do it is it's a configuration, not as part of the process, because it's not defined as when you define the process you to choose that, but it's more at the runtime you configure your system to start doing that. So you can basically on deploy time, when the project is deployed, you can, system administrators can identify some of these. They can turn on the monitoring, and at that point, all that component does is it gets the input so it can start learning and training the algorithm. And it just adds additional data. So the task itself, it doesn't even know that it's coming from machine learning. All it knows is there's additional data that you can visualize. So that's why it's configured as, currently it's kind of like a system administrator who's able to configure that for specific tasks. Yeah. Yeah, we've not, that would be possible, and we've seen several use cases where we're applying certain technology to try and identify process mining, to try and identify which might be good candidates. That would be a valid approach. So far, we've only done a pretty manual approach of selecting these tasks. All right, thank you.